Welcome, my dear students in Prep 3. Let's continue Lesson 1 in Algebra. Lesson 1 was about Cartesian product. We studied Part 1 in the last session. It was about ordered pair, and we said that two ordered pairs are equal if the first projection in the first ordered pair equals to the first projection in the second, and also the second projection in the first point or ordered pair equals to the second projection of the second point. Today we will continue this lesson, and we want to know what do we mean by Cartesian product. Cartesian product is between sets. Okay, if you have two finite sets, you can get the Cartesian product between them as follows. Let's see. For any finite and non-empty sets, x and y, for example, we get the Cartesian product of the set x and y, and we denote it by x times y like this. Okay, this is the set of all ordered pairs whose first projection is from x and second projection from y. So I take the first projection from x and the second projection from y to get the Cartesian product between two sets, x and y. Here, for example, it means that x by y equals the set of all ordered pairs a and b, such that a belongs to x and b belongs to y. Okay, to understand this Cartesian product, we will take an example. Here, for example, we have two sets. The first set is 3 and 4. The second set is 5, 7, and 8. So set x is 3 and 4. Set y is 5, 7, and 8. I want the Cartesian product. How to get the Cartesian product between the two sets? We said before, this is the set of ordered pairs. So I'll write ordered pairs. Each one of them has two projections. The first projection will be from x. So if I choose the first projection is 3, I can write ordered pairs. The first one 3 and 5, and also 3 and 7, and 3 and 8. Now we have 3 ordered pairs. Okay, then I'll choose 4 as a first projection. So we will have 4 and 5, 4 and 7, 4 and 8. So we will have 6 ordered pairs in the set of the Cartesian product of the two sets x and y. Okay, I want x by y and y by x. I want the Cartesian product of x by y and then y by x. Okay, the first one, as we said, I write, at first I'll choose the first projection from x. So, and the second projection, all the elements of y. So I'll take 3 and 5, 3 and 7, 3 and 8. Then I'll take 4 as a first projection. So I'll take 4, and the second projection will be from y. So I have 4 and 5, 4 and 7, 4 and 8. Okay, now what about y by x? Cartesian product of y by x. By the same way, but this time I should take the first projection from y, because here y is at the first. So I'll take the first projection from y. So it will be 5 and 4, 5 and 3. Then 7, 7 and 4, 7 and 3. Okay, and finally, also I'll take 8. So now we have 8 and 4 and 8 and 3. Okay, so this is the Cartesian product of y by x, and this is x by y. Okay, as you can notice here, the Cartesian product x by y doesn't equal y by x. They are different. Can you see here, for example, 3 and 5, there is no 3 and 5 here. 3 and 7, there is no 3 and 7, and so on. Okay, so the Cartesian product x times y or x by y doesn't equal y by x. Now we know how to get a Cartesian product of two finite sets by taking I write an ordered pair. Each ordered pair consists of two projections. The first projection should be from the first set. For example, here x and y. So the first projection should be from x and the second projection from y. I write all the ordered pairs in which the first projection is from x or belongs to set x, and the second projection belongs to set y. Okay. The number of elements of any set I'll denote it by n of x. Okay, the number of elements is n of x. So if you see n of x, it means the number of elements of set x. Okay, for example, if the number of elements of set x equals 2 and the number of elements of set y equals 3, so set x consists of 2 elements and set y consists of 3 elements. It means that if I make a Cartesian product between x and y, okay, in this case the number of elements of this set, the Cartesian product set, will be 2 times 3, which is 6. Okay, like here for example, the number of elements of set x 2, and here the number of elements of set y 3. 3 times 2 equals 6. As you can notice here, the number of elements of x by y Cartesian product 1, 2, 3, 4, 5, 6. Okay, each ordered pair is an element. We consider each ordered pair as an element. Okay, so if you have the number of elements of the first set x, and the number of elements of set y, you can get the number of elements of the Cartesian product set. Okay, let's continue. Also, we have a Cartesian product of the set x by itself. Okay, it's denoted by x or x2. We call it x2. In this case, I'll make a Cartesian product of the set by itself. Like for example, if x equals 1 and 2, imagine that you have another set x also, which is 1 and 2. So in this case, the ordered pairs will be, I'll take the first projection from here, so we have 1 and 1, and we have 1 and 2. Then I'll take 2, so you will have 2 and 1 and 2 and 2. Okay, so the Cartesian product of a set by itself, you can do it by imagining that you have another set which is x also. Then I'll take the first projection here, 1 with itself 1 and 1 and 1 and 2, then 2 and 1 and 2 and 2. Okay, also here we have the number of elements of set x. We have 2 elements, 1 and 2. So the number of elements of set x2, it will be 2 by 2 is 4. 1, 2, 3, 4. Okay, now we want to know how to represent the Cartesian product. We can represent the Cartesian product by 2 ways. If we have 2 different sets, we can do it by 2 ways. The first way is called arrow diagram. So we can represent the Cartesian product using arrow diagram. The second way is Cartesian diagram or graphical. Okay, so we can represent the Cartesian product using arrow diagram or Cartesian diagram. How can we do that? Let's see. Here, for example, I'll draw set x and set y. Okay, set x, for example, consists of 1, 2, and 3. So imagine that set x consists of 1, 2, and 3. And also I have set y. Set y consists of 5 and 8. I want to represent the Cartesian product between x and y. Okay, I'll draw an arrow from each element in X to Y. Now I'm representing X by Y, not Y by X. So the arrow will start from 1 to 5, then from 1 to 8. This is number 1. From 1 to 5, then from 1 to 8. Then I'll take the first projection also from X, always the first projection from the first set. X by Y, it means always the first projection from X. Y by X, it means the first projection from Y. Now I'll take 2, so I have 2 and 5, 2 and 8. And finally 3, 3 and 5, 3 and 8. This is an arrow diagram. So I can represent the Cartesian product using arrow diagram. I draw at the two sets, for example X and Y, and I'll draw an arrow from each element of set X to each element of set Y. Okay. The second method is using Cartesian diagram. In Cartesian diagram, it's similar to the XY axis diagram. Here, for example, we have X and Y. X consists of 1, 2, and 3. Y, this is the first projection, and the second projection, Y, 5 and 8. Okay, I put a point. For example, 1 with 5, so I draw a point here. 1 and 2, this is 1 and 5, this is the first point. Then 1 and 8, the second. Here 2 and 5 and 2 and 8. So we have now points 1 and 5 and 1 and 8. This is another point. Each point is an ordered pair, 2 and 5 and 2 and 8. So this is the Cartesian diagram to represent the Cartesian product of two finite sets X and Y. Okay. 3 now, 3 with 5 and 3 with 8. Okay, so from each point or from each element on X, I put a point to each element in Y. Here X1, 1 with 5, 1 with 8, this is the first 2 points. 2, 2 with 5 and 2 with 8, so we have another 2 points. Here 3 with 5 and with 8. So this is the Cartesian diagram and this is the arrow diagram. Okay. If you have, for example, x1 and 2 and I want to make x by x or x2, in this case also we can represent it by one of the following diagrams. The first one, for example, here I have 1 and 2 and the arrow will be from 1, here from 2 to 1 and from 1 to 2 is the first. Then from 1 to itself, an arrow goes from 1 to itself, okay, and also from 2 to itself. So this is another arrow from 1 to itself and another one here from 2 to itself. Okay, this is the first way. So we can draw the set X only one time, and then I'll draw arrows from each element to itself one time and to the other elements and the other time. Or we can use the arrow diagram and we can draw X 2 times. We can draw the set X 2 times. As we said before, if we have 2 different sets, then this is an arrow from 1 to 1, from 1 to 2, and from 2 to 1, and from 2 to 2. What about the Cartesian method? Yes, also we can draw it. Here we have X and X, 1 and 2, 1 and 2. This is the first projection, always the first projection on X-axis, the second projection on Y-axis. Okay, so we have the first point 1 and 1, 1 and 2, also 2 and 1, 2 and 2. Okay, so we can do it by the 3 methods. We can draw only the set one time, or we can draw it 2 times and make arrows, or we can use the Cartesian diagram. Okay, now we have an exercise. If x equals 2 and 3, y equals 1, 2, and 4, z equals 1. Represent x, y, and z by Venn diagram. Do you remember Venn diagram? You studied Venn diagram in primary 5. The Venn diagram, you will draw a closed shape, circle or rectangle or whatever, a closed shape, and each closed shape represent one of the 3 sets. The intersection zone, I write the intersection between each 2 sets and the intersection zone. For example, here we have x consists of 2 and 3. This is 2 and 3 inside a closed shape. This is Venn diagram. Then we have y consists of 1, 2, and 4, but here we have 2. So 2 will be in the intersection zone here. Okay, so we still have 1 and 4. This is 1 and 4. Finally, we have z. Z is a subset of y, so I draw it inside y. Okay, so this is the first required. Draw Venn diagram x, y, and z. This is the Venn diagram. Okay, then find x Cartesian product by x intersect y. Okay, so where is x intersect y? X intersect y point 2. Okay, x intersect y is 2. So this is the Cartesian product between x, z and 2. So the first set here is z, the second set is 2. Where is z? 1. So we have 1 and 2. Okay, so z times x intersect y, it means z, we said z is only 1. This is z, consists of only one element. Okay, and x intersect y also only one element. 1 times 1 is 1, so I know that the result will be a set of 1 ordered pairs, which is 1 and 2. Okay, this is the first required. Let's move to the next one. Now I want z by x union z by y. Where is z by x? This is z, which is 1. X is 2 and 3. So it will be 1 and 2, 1 and 3. Okay, what about z by y? This is z and this is y. So 1 and 1, 1 and 2, 1 and 4. Okay, so now I have the first one is z by x. Z by x, it means the first element from z and the second element from x. So I have 1 and 2 and 1 and 3 only. Then z by y, this is z and this is y. So I have 1 and 1, 1 and 2, 1 and 4. Okay, now I want the union of the 2 sets. What do you mean by union? It means all elements, but please don't repeat. So you have 1 and 2, 1 and 3, 1 and 1, 1 and 4. But don't write 1 and 2 2 times. Don't repeat, okay? So it will be 1 and 2, 1 and 3, 1 and 1, and 1 and 4. Okay? So this is about our session today. We still have a third part of Cartesian product. I hope you have understand our session today. Next session we will continue part 3 of Cartesian product. Today we learned how to make a Cartesian product between 2 sets, between 2 finite sets, and how to represent it. Next session we will continue part 3. Thank you very much for watching, and goodbye.